Geometry Unit, Section 3, Surface Area. Three-dimensional objects have length, width, and depth. Sometimes it is useful to be able to compute the area of the surfaces that make up that object. In this example, it's asking us how much material or sheet metal is needed to fabricate a tank built to these specifications, and how much will it cost. When you determine the area of all the surfaces of an object, this is called total surface area. Here we have a rectangular solid, and it has 6 sides. We have the front and back, the left and right ends, and the top and the bottom. Each of these sides is in the shape of a rectangle. To find the total surface area, we'll find the area of each one of these, and then add all 6 of those areas together to give us a TSA, or total surface area, in this example of 641 inches squared. You may have heard the term lateral in football, where we're passing the ball parallel to the end zone. But sometimes we're only interested in the area of the vertical sides of a rectangular solid, not the top and the bottom. The mathematical term for this is the lateral surface area. Applications of this come many times from construction, where we need different paint on the walls versus treatment on the ceiling and the floors, and paneling. Normally walls are paneled, ceiling and floors have different treatment. To find the lateral surface area of a cylinder, if you cut a cylinder vertically and open that piece up, it forms a rectangle where the width here of that rectangle is formed from the circumference, or the distance around that cylinder originally. The circumference is found by taking pi times the diameter. The length of our rectangle here is the height of our cylinder. We have a rectangle that we then can determine the lateral surface area, not including top and bottom, for this cylinder. And our formula then results in circumference, pi times the diameter, times the height of the can. In this example, they're asking us to determine the cost of a sheet metal to make an open-ended tube, and they give us the price for the sheet metal per square foot. Here we have our cylinder. It has a overall length, or if we had this on its end, a height of 45 inches. We have a diameter of 18. When we slice this cylinder, we have a rectangle that's 45 for our height, or length of the rectangle. This dimension on the right hand side is the result of our circumference of the cylinder, which will be found by taking pi 3.14 times the diameter of 18 inches, the distance across the circle at its widest point. Now that we have the 2 dimensions of the rectangle, we can calculate the lateral surface area of the cylinder by taking 45 times 56.52. This problem is asking us to determine the cost, and the cost for sheet metal is $1.53 per square foot. we have a problem. Our lateral surface area is in square inches. So a preliminary step to determining the cost is to convert our square inches into square feet. To do that, we need a conversion factor, and you should find on your conversion table there are 144 square inches per 1 square foot. If you take the lateral surface area in square inches and divide it by 144, the result is 17.7 square feet. Now we're ready for the final calculation to answer the question. To determine the cost, we'll take our area times the cost per square foot, resulting in $27.08. Additional surface area problems are found on page 43.